Now let's talk about polymers. First of all, let's understand the difference between macromolecule and a polymer. Both of them basically are high molecular masses, the molecules having high molecular mass. But polymer is a molecule that has monomers, small repeating units that has monomers. So if we say that macromolecules are polymers, then it is a wrong statement. But if we say that polymers are macromolecules, so that is a correct statement. So this is the difference between a macromolecule and a polymer. Now next we have homopolymers and copolymer. So if a polymer that consists of same type of monomers, a single type of monomer, that is termed as a homopolymer, while if it contains different type of monomers, that is called as a copolymer. So a polymer having same type of monomer is termed as homopolymer, while a polymer having different types of monomers is termed as copolymer. So examples of homopolymer, they can be neoprene, Teflon, polythene, or nylon 6 or starch. So examples of copolymers, they can be nylon 6 terylene, etc. Now let's classify the polymers on the basis of their source. So they are classified basically into three categories. Number one is the natural polymer. So examples of natural polymer is cellulose and natural rubber. So nucleic acids is also example of a natural polymer. Next we have synthetic polymers that are basically produced in labs and factories. We have nylon, polyester, plastics and synthetic rubbers. We are not talking about natural rubber, we are talking about synthetic rubbers. So next is the semi-synthetic polymer, or we can say modified polymers. These are basically obtained by the modification of naturally occurring polymers. So examples, we have vulcanized rubber, in which we basically heat the natural rubber in the presence of sulfur. Another example can be rayon also, that is basically obtained by modification or acetylation of cellulose. Now let's classify the polymers on the basis of their structure. Now based on structure, they can be linear polymer, branch chain polymers, or three-dimensional polymers. Now if we talk about linear polymer, they have close packing, they have high melting point, they have high density and high strength. So examples are PVC, nylons, polyesters. Now let's talk about the branch polymers. Branch polymers, they basically have branches. Linear polymers doesn't have any branch. Branch polymers contains branches, and they have basically low melting point and low density. Examples are polythene or amylopectin or glycogen. Basically branch chain polymer, you can say low density polythene is also example of a branch chain polymer. Next we have a cross-linked or a 3D network polymers. Now in this we have highly cross-linked chains there. So they are hard, they are rigid, they are brittle. Examples are bakelite or urea formaldehyde resin. Another example is Malmac, that is melamine formaldehyde resin. Now let's classify the polymers on the mode of their polymerization. So based on the mode of polymerization, we can have addition polymer and condensation polymers, or addition polymerization or condensation polymerization. In addition polymerization, basically it is formed of addition of monomers, and in condensation polymer it is again formed of addition of monomers but with the elimination of some small molecules. Now addition polymers are also known as chain growth polymers, while condensation polymers, they are also named as step growth polymers. So the basic difference between addition polymer and condensation polymer is condensation polymer includes the elimination of small molecules just like H2O, alcohol, CO2, HCl, or ammonia in some cases. So this is the difference between addition and condensation polymers. Now let's talk about stereochemistry of polymers. We have basically three types of polymers. One is isotactic, that have same order. Next is syntactic, that are alternating, and the last one is atactic, having no order. So these are basically the representation of the three forms. If we try to understand isotactic, we have same arrangement, and if we talk about syntactic, there is alternate arrangement, and if we talk about atactic, there is no order in the arrangement of the substituents. So next point to important to note here is that radical polymerization that usually gives branch chain atactic polymer. So this point is again important one, that radical polymerization usually gives branch chain atactic polymer, and formation of these three, it basically depends upon the temperature, pressure, as well as the catalyst. Now let's classify the polymers based on the molecular forces. There can be different molecular forces present in the polymers. They can be van der Waals forces of attraction, there can be hydrogen bonding, or there can be dipole-dipole interactions. So please remember that greater is the length of the polymer chain, stronger will be the intermolecular forces. Now let's study about polymers one by one based upon their molecular forces. The first one is the elastomers, then is the fiber, then is thermoplastic, and the last one is thermosetting. First of all, let's talk about elastomers. Elastomers are basically polymer chains. They are held together by weak van der Waals forces of attraction. These are also named as amorphous polymers. So the forces present are weak van der Waals forces. Now degree of elasticity in them is very high. They are basically randomly coiled molecular chains of irregular shape having few crosslinks. So these are basically stretchable polymers. So weak van der Waals forces of attraction, they permit the polymer chains to be stretched, while the crosslinks, they help the polymer to come back to the original position. So these 2 points are also very important. Examples of them are vulcanized rubber or Buna S. Buna S is also named as SBR. Now that is all about the elastomers. Now let's talk about fibers. The second type is the fiber. Fibers are the polymeric chain. They are basically held together by strong dipole-dipole interactions or hydrogen bonds. So they have high tensile strength. They have least elasticity. The molecules are basically long, thin, or thread-like. They have high melting point and low solubility. So these are some important points regarding fibers. They are mostly used to make fabric. Examples are many, like nylon, which is basically a polyamide. There is hydrogen bonding present in nylon. Next is the polyacrylonitrile, also named as Orlon or acrylon. Now there is a cyano group present in polyacrylonitrile. Next is the polyester. The polyesters contain tyrrolene and dacron. There are dipole-dipole interactions in them. Polyesters contains carbonyl group. Now let's talk about the third type, that is the thermoplastic. These polymers, they are basically linear or slightly branched. The intermolecular forces are in between the elastomers and fibers. Now they are hard at the room temperature, but they can be made soft on heating. Most important point about them is that they can be remolded again and again. This is very important point of thermoplastics. They can be remolded again and again into different shapes. So they have little or there is no cross links present in them. Examples include polythene, polypropylene, polystyrene, PVC, Teflon, nylon 6, nylon 6,6, polyvinyl acetate, polyacrylonitrile, and polymethyl acrylate. Now there is a special mentioning about plasticizers. Plasticizers are basically, there are some plastics that don't get softened on heating, but they can be made soft with the addition of some compounds that are basically termed as plasticizers. Examples of plasticizers include dialkyl phthalate, di-N-butyl phthalate, di-N-octyl phthalate, and cressyl triphosphate. So in PVC, during the polymerization process, di-N-butyl phthalate is added. There are basically a question given in NCERT based on the order of the molecular forces present in different polymers. So nylon 6,6 will have a maximum force of attraction. Next, the last part is the thermosetting. Thermosetting are basically semi-fluids. They have low molecular mass. There is a permanent change in chemical composition on heating, so they cannot be remolded again and again. This is the difference between thermoplastic and thermosetting. Now examples include phenol formaldehyde, that is bakelite, urea formaldehyde, and melamine formaldehyde. Let's study about the classification based on the type of mechanism that is involved during growth of polymerization chain. First we have addition polymers that are also named as chain growth polymers. So intermediates formed during the process, they can be free radical, they can be carbocation, there can be carboanion. The second part is the condensation polymer, that is also termed as a step growth polymers. Now first study about chain growth polymers. First one is the free radical polymerization. Now free radical polymerization of alkenes or conjugated dienes that basically require some initiator, we say as a radical initiation. This process includes three steps. The first step is the chain initiation, or radical generating catalyst should be there, or radical initiator should be there. Most important one is the benzoyl peroxide. Benzoyl peroxide basically creates a radical by homolytic cleavage. There is homolytic cleavage that ultimately forms phenyl free radical. For the further process, there can be another initiator, that is tertiary butyl peroxide or acetyl peroxide. Ethene polymerization that basically includes oxygen or benzoyl peroxide as initiators. The second step is basically chain propagation, in which a free radical combines with the alkene molecules to further generate a free radical that further attacks with alkene molecule, and so on. And the last step is the chain termination, that can be done by combination of free radicals or by disproportionation of free radicals. So that is all about the free radical polymerization.